So if one, let's say that effectiveness 1 has got time t, okay? Then, and we know that in total it's 30 hours. How can you express time for effectiveness 2 in terms of the first variable?
T minus 30?
Why t minus 30? If 30 is the total.
30 minus t.
Exactly.
Yes.
So then the second one will be 30 minus t. So that's why we align the variables, right? We align the variables because we have to deal with one variable in the function. So that means that we will not just combine the functions, we will not just add them up together, but we also will take this into consideration, okay? So now we're going to model the equation of the total effectiveness. Again, if you don't understand anything, just stop or interrupt me and ask your question. Total. Okay, so Habiba, can you tell me now the equation of the total effectiveness function based on what we have just discussed? Habiba.
Miss, is it going to be so E1?
This is already, we don't want to repeat this.
Yeah.
Already there.
We're just going to input 0.6
Yes.
times 9.
Okay, so the first one
It's
we'll
going
leave
to
it as
basically
t,
stay the
right?
same. Yeah.
T minus t over 20.
And then the plus
what about the
E2,
other one?
Yeah, the 0.5.
But we're going to put the 30 minus t in there.
Instead of why at the end?
Instead of
how many
t.
times?
Instead of t.
So
Twice.
how many times do you see it?
2 times.
2 times. So
One in the
here
exponent and one in the
30 minus t, and then the other time in the exponent. 30 minus t over 10. Okay. Right. So this is the function we're going to work with, and we're going to look for its maximum effectiveness. So we're and eventually we'll solve for time, right? So what time allocated to the first and to the second exam going to maximize the effectiveness? Right. According to our algorithm, what's the next step?
Find the derivative.
And just a second. Okay, so E prime. Okay, so I'll ask different people. Please do not jump if I didn't call your name.
Okay, so I have a question first.
The
0.6 is just gonna stay as a constant, right?
That's true. Yes, this is what I keep talking about. Right. So let's find the derivative of the first expression. Mohammed, the derivative of the first expression, please. So 0.6 we said stays as a coefficient. So you need to only find the derivative of whatever you see inside the bracket.
Okay, so would it be 1 plus?
Why 1 plus?
No.
Okay, let's look into each term separately. What is the derivative of 9?
0.
So the derivative of 9 is 0, so it's not there. Now let's look at the second part of this expression. You have t and e to the power of something. So what kind of rule you think you should apply here?
Power rule.
Mohammed. Okay, so can you please apply power rule to this expression?
Okay, so negative t.
Why is it negative? According to power rule, the first thing you do is the derivative of the first term, of the first factor in the product. What's the derivative of t?
1.
1. And then when you found the derivative of the first function, what do?
You add it to the...
No, you multiply it by the second function.
Yes. And then,
so that means that only e to the power of negative 2 over 20 is going to be left. Now do the second part of the product after plus.
t.
Mm-hmm.
and then times negative.
Still negative. Why negative? Because what? Tell me.
Like we do the negative t times the e. Like
Negative t
the
times e. Like power law?
yeah.
Okay. No, it's not working. Power law is not working for exponential functions. Mohammed, we're dealing here with the function e to the power of x. What is the derivative of e to the power of x?
1.
No.
Oh no,
E
oh,
Guys,
sorry,
you know?
x.
Yeah?
T to the power of x.
It stays the same. Okay. And then in this case, you have instead of x, you have negative t over 20. So it is becoming an inner function. So you need to think about its derivative as well. So Mohammed, what's the derivative of negative t over 20?
Okay, so it's gonna be negative 1.
The derivative of negative t over 20. In order, guys, to answer this question easily, you need to see what's the coefficient of t. What is the coefficient of t?
1.
Okay, but 20, what about 20? So you can split this expression into two parts, negative 1 over 20 times t. Do you agree that this is the same thing?
Yes.
So now it's very easy to find the derivative, right?
20t.
Mohammed, what is the derivative of this expression? If the coefficient is negative 1 over 20, what is the derivative of 5x?
This is 5. Oh, so the derivative is t.
What is the derivative of 5x?
5.
Yes. So what is the derivative of negative 1 over 20 times t?
It's just t.
No. Any other ideas, guys?
Negative 1 over 20.
Yeah. So, Mohammed, it's coefficient, right? If you have a variable in the first power, then it's just the coefficient. What is the derivative, right, of it? Why? Because the derivative of x is 1. So the derivative of t is 1. So what's left is the coefficient only is left. Negative 1 over 20. Okay. So, guys, everything I write in blue is like comments, right? So something like I work on the side. I will keep it in a different color because I'm going to keep this as a reference for you. Let's go back where we stopped. So all of this we were doing in order to find the derivative of e to the power of negative t over 20. Do you think that you can collect it all together now, Mohammed? So we need to write down the derivative of e to the power of negative t over 20.
Would it be e to the power of negative 1 over 20?
No, it will be e to the power of argument the way it is. According to the chain rule, you don't change it. Okay? And then you multiply by the derivative of the inner function. Then you multiply this by the derivative of the inner function. So what is the derivative of the inner function?
Negative 1 over 20.
Exactly. Times negative 1 over 20. Okay. That's it. So this is the product rule, right? So t times the derivative of this function. So we finished this part. Okay. So now we're going to do the derivative of the second expression here. Just 1 second. Okay, so I need someone to do the derivative of the second expression.
Yes, I can do it.
Nur Fahmi. Nur Fahmi.
Yeah, maybe you said you can do it, yeah, miss. I don't mind.
Nur, grab the opportunity. We're practicing. I'm not beating anybody here, right? We're just practicing.
Okay, so it's gonna be
the second function?
0.5.
Okay. All right. Now
And
let's
then
think about
the 10 cancels out, so it's like, because
Yeah.
it's 0.
Exactly. So what should you think about
And then
when you look at this?
it's like product rule.
Product rule, absolutely. Okay. So tell me how the product rule will look like here.
So it's gonna be like e to the power of negative 30 minus t over 10.
So you found, that means that you found the derivative of 30 minus t. What is the derivative of 30 minus
It's 1.
t? Any
it's negative 1,
objections? Negative 1. So it means that, what should I write in the first place of product?
Negative e
Mm-hmm.
to the power of negative 30 minus t over 10.
Mm-hmm. Just 1 second. Adam, сделай тише прямо сейчас. All right. And now in the second place
plus
of the... Mm-hmm. Mm-hmm.
In bracket 30 minus t.
30 minus t. Mm-hmm. Just a second, I'll make it a bit smaller. Я сказала сделать тише прямо сейчас. Еще. 30 minus t, and then? Nur.
And then times.
Okay, this point is difficult. Let's take it out and think about it separately. So e to the power of negative 30 minus t over 10.
Miss, isn't it going to be 1 over 10?
Yes. Are you that smart? Like, how did you figure it out, Tom? No, it's not
because
just
we know
1 over
that
10.
30 minus t is going to be negative 1, and there's a negative outside, so the negative times the negative 1, it's going to be 1 over 10.
Okay, but like not exact, not like when you're saying 1 over 10, it's all what? It's the derivative of the inner function, right?
Yes.
So Noor, I don't know if you understood what we're discussing. Tell me what's the derivative of the whole thing of the composite function.
It's going to be 1 over 10 e to the power of negative 30 minus t to the power of 10.
1 over 10,
over 10, sorry.
E to the power of negative 30 minus t over 10, right? Guys, any questions about this part? Because it was a bit fast. Okay, so no questions, then let's move on. So let's move on and put this derivative here. So 1 over 10, 1 over 10, and then times e to the power of negative 30 minus t over 10. Okay, good. So this is the derivative of the function, right? What are we going to do next, according to the algorithm?
Equate it to 0 to find the 0.
Equate it to 0. Okay. And when we, Habiba, when we equate it to 0, what we're going to do next? Habiba.
Factor?
No. This is a bit, again, Abdurrahman. Marwan Ayub, are you here?
Yes.
What do we do after we found the derivative?
Equate it to 0.
We equate it to 0, and then what?
And then we solve.
Solve for t in this case, right? And
Yes.
when we solve for t, when we equated it to 0, and we are going to solve for t, what is the best form, guys, again, for a solution?
Make it 3 arguments.
Factored form.
Factored form. So we need to do the factored form. So equate it to 0 and factor. Because this is the only way to solve this kind of equations. Factor. And this is the main challenge of this question, factoring. Okay, so we'll be factoring twice to be able to solve it. Okay, let's do it. So let's so that to save time, we will right away start factoring. What are we factoring? You have to highlight. So this is the first big expression, right? This is the first big expression, and this is the second one, right? So first, we'll only think about inside the brackets. okay, inside the bracket. So if you check the inside the brackets here and inside the brackets here, so let's check the first one. What is the common factor inside the first brackets?
E.
E to the
To the
power
power
of
of
E to the
negative.
power of
20.
negative t
Negative
over
t.
20.
Yeah, so let's factor it. Mina, are you here?
Yes.
Okay, can you factor, please?
Okay, so it will be we will take e to the power of negative t over 20 as common factor.
Yeah, but also 0.6 will stay, right?
Yeah,
So
yeah.
it's a coefficient, so I want to keep it in the front. So 0.6
So it will be
times
0
e.
times
Mhm.
e to the power of negative t over 20. And then the
All right.
bracket,
So now
it will
what's
be
left? Mm-hmm.
1
Mm-hmm.
plus t,
Mm-hmm.
and then the bracket.
So look, can you multiply t and negative 1 over 20? What will it be?
Okay, it will be negative t 1 over 20.
Negative t over 20, right?
Over 20, yeah.
Negative t over 20.
And then
Yeah,
the next
okay.
one,
The next one, I want Marwan Gideawi, please. What other names do I have in this
Yes.
group? Yeah, no, Marwan Gideawi. Look at the second bracket and tell me what is in common to factor out, to be able for us to factor it. What's in common?
The second bracket, where?
Yeah, this is the second bracket where I'm coloring it now.
The blue one? Oh, I mean, okay.
Yeah, what's the common factor in the second bracket?
E.
No, e is not alone. E comes always with an exponent, right?
Yes.
So the exponent is the same or different?
The same.
The same. So and 0.5 outside will stay, right? So 0.5 times e to the power of negative 30 minus t over 10. So this is the common factor. Now, Marwan, you will tell me what's the leftover in the bracket.
Okay.
So what's left from the first term? Look, it used to be negative e to the power. So what's left?
Negative E.
How?
negative
What's
1.
left, guys?
Now it's
Negative 1. Negative
negative
1 is left. Marwan, what's left from the second expression?
negative
Here.
I think
You took e to the
I
power of
think
out. What's left?
3.
3. Only?
30
Okay.
minus t times 1 over 10.
Yes, but if you distribute, maybe Marwan decided to distribute right away. I don't know. So actually, 30 times 1 over 10 is 3. So plus 3. And then Marwan.
And then 10
Minus
or minus T
over.
Over 10.
Mm-hmm.
over 10.
Okay. Yeah. Okay. So all of this stuff is equal to 0. Okay. So
From where did you get the negative 1?
where did we get the negative 1? Who can explain?
Because
Because when we factor out,
Yes.
because we have
Mina.
we have a common factor as e without the negative e to the power of
Yes.
negative 30 minus t over 10.
Mm-hmm.
So the rest is negative, so it will be negative 1.
Mm-hmm. Marwan.
Nice, okay. Thank you.
Okay.
Welcome,
So
Marwan.
now, what we're going to do, I want you to understand the logic. Now, the second time when we are going to factor this expression and this expression should become identical so that we can factor it out. Okay, and now you will see that it's very close. Actually, they are very close. Let's separately. I'll just do this so that I don't repeat this again and again. If I collect like terms here in the second yellow bracket, what will it look like? Abdurrahman.
which Abdurrahman?
Maergi.
Yes, miss, sorry, what was the question?
Collect like terms. in the
If we
second
collect
little
like terms,
bracket.
so it's going to be 2 minus t over 10.
T over 10.
And then we're going to
Okay.
put t over 10 on the other side.
No, which other side? There is no other side.
Okay.
There is no
So
other side. So my question is, so how to make the first, look here, this one, this expression, and this expression, how to make them look the same?
Multiply it by 2.
we divide the first one by 2.
Divide by 2.
Divide the first one by 2. Okay, we cannot
No,
multiply
let me
or
see.
divide anything because you will change then the
Yes.
expression. So, but we can factor.
Factor
So-
out 1 minus t over 10.
To be able to factor it out, we have to make this one look like this, but it doesn't. There is one thing, small detail. We need to factor something out to make it the same like the first one.
The 10?
Okay,
No.
try. If you factor out 10, you need to divide 2 by 10. It will be what? 1 over 5.
And the other
Will
one
it give you?
No. We factor out 2.
We factor out 2. Exactly. So let's factor out 2. So what will be left, Abdurrahman?
1 minus
Okay.
t over 20.
This is your guessing, right?
Yes.
Okay, so let's verify. Let's make sure that this is true. So when you factor out 2 from this expression, from 10 over from t over 10, you're dividing by 2, right? You remember I told you factoring means you divide by the common factor.
Yes.
So let's check it. T over 10 divided by 2. How do we divide by a whole number?
Multiply by 1 by half.
Exactly. Multiply by half. It means that we need to take t over 10 and multiply it by
It's
half,
going to be 1 over t over 20.
which is t over 20. This is the twist of the question, basically, because it's not straightforward how you are
This,
factoring here,
this
right?
was the easiest part.
Really?
The hard part was the
From my experience,
The derivative one.
the derivative
Yeah.
was
Why did
really
we have to do
The
this?
derivative was real hard.
why did we do this? Because, reasonable question, because we want to have, now I don't know which other color will it, we want to have this and this the same. Why? Because we're going to factor out again. Because we will keep factoring until we have a product. Do you see that we don't have a product? We have a plus between them. So now we need to factor out something from the entire expression, which is in the first place, in the sum, and the entire expression in the second place. And this common factor is going to be 1 minus t over 20. So let's do it. So I'm going to write down the common factor, which is 1 minus t over 20. And Marwan Ayub, you will tell me what's left. Okay?
Okay.
What's left from the first thing? From the first expression in this sum? What's left?
For the 0.6 0.6 e
0.6 e.
to the power of negative 10 no
Yes, correct. Correct.
over 20. And
Now
the second,
let's look at the second expression. Look at it. Don't forget that we factored
the
out
2.
2 as
Yes,
well.
2.
So 2 is there, but not
Or-
only. What else is
come on.
there?
What else is there?
This
The
is the whole, yes, 0.5.
0.5
And then what else?
e
Mm-hmm.
to the power of negative 30 minus t
Mm-hmm.
over 10.
Mm-hmm.
And
Yeah, all of it is equal to 0. Okay, so good. Now, guys, finally, we have what we wanted. We wanted to have a product. So we have a product of this expression, right? And this expression. They are multiplied. Let me remind you that a product is equal to 0 in 2 cases. Either you have both factors multiplied, both of them are zeros, or only one factor is 0. What do I mean? For example, you have 3 times 0 is 0, right? It means that one factor is 3 and the other one is 0. The product is 0. This is the first case. The second case is when they are both zeros. So based on this, we are using this
So
mini
the
equations,
entire
right?
function is 0, right?
The entire function is 0 because this is derivative, we equated it to 0. So we need to check if both of them are zeros, the blue one and the green one, or only one, okay? Because if both of them can be equal to 0, then what do we need to do? We need to equate both of them to 0 and find the solution for both of them, okay? So
Miss,
my
but
question,
wouldn't the first one be undefined?
why? No, the first one is 1 minus t over 20 equals 0. Is it possible? Possible.
Yeah.
You're confused, Abdurrahman, because we were speaking about fraction, if there is a fraction. But the fraction here is added or subtracted with another number, this first thing. So it's not alone.
So the first fraction cannot be equal to 0.
So it's going to be
Just a second,
negative
guys.
t
The
over
first
20 equals
blue,
1.
okay, so negative t, white 1. Yes,
So we're gonna
negative t over 20. Yes, you're right. Is equal to negative 1. Negative 1, right? Because you move
how is it?
the
Yes, yes,
Isn't
yes,
it
yes.
simple to move the negative t over
Oh,
20
Miss
to the other
Natalia.
side?
whatever. It
It will
doesn't
be
matter.
negative.
So, anyways, what's t?
We'll
T is
multiply
20,
by
right?
20.
T equals 1 over
Because
20.
So it's 20.
no, t is 20.
Yes,
T
it's
is 20.
20.
Okay, so there is a solution in this equation, right? Now let's consider the other one, the green one. Okay, so my question is it possible for this equation to be equal to 0?
No.
Well, yeah, because I'm asking this question, right? So
Because it's
no, it cannot
undefined.
be equal to 0. It cannot be equal to 0. But why? This is
Because
what we
of
need
the
to
E.
Exponents are undefined.
Miss, it's because of the E.
Well, because of the E, that's good, but we also have a sum here, right? It's one
Yes.
expression plus the second expression. So you
Both
have
expressions
to
are undefined.
undefined when what? When it's equal to 0, you
when
mean? Okay, there is another way to think about it. So how can you explain that? I'm asking you, what can you say about the output of this? Like, is it positive, negative, or 0? This one. You can say for sure whether it's positive, negative, or 0. 0.6 is positive.
Yes.
It's positive.
So what?
Positive.
Okay, what about e to the power of negative t over 20? Is it positive, negative, or 0?
Positive.
Positive. Noor, why is it positive?
Because the exponent will make it like close to 0, but it won't make it 0. That's what I know.
Yes, yes, but like still, how do you know that it will make it close to 0?
Because the exponent can make it negative again.
Okay, so in other words, e is a, guys, who remembers approximately what's the value of e?
E to the power of x?
2 point something, okay? So 2 point something raised to a power, will it be ever negative?
No.
No.
Never, right? Will it be ever 0?
No.
No.
So it means that it's always positive, right? And if you multiply a positive constant, 0.6, by a positive number, what will be the product?
Positive.
Positive. That's not enough. Now, let's consider the other one. This is, by the way, 2.0.5 is 1, by the way, right?
Yes,
So
it's gonna be
we
10.
can only say that e to the power of negative 30 minus t over 10 is definitely positive for the same reason. But that's not enough. We also need to note that they are added, because if they are subtracted, the output might be negative, because if you subtract 5 and 10, although they are both positive, the output is negative, right? So when you have a subtraction, you cannot say for sure. But here, because of the addition, two positive numbers added will always give you a positive. So it means that the entire green thing is positive, not 0.
So we
Positive.
only have 1 0, and that's t equals
Exactly.
20.
So it means that the green one will never be equal to 0. It means that this product is 0. Why? Because the first one is 0. Okay. So this this kind of, sorry, you got it?
Well, I got the same answer, but when I didn't do all this, but I got the answer like twice. Like t is equal to 20, I got it twice.
What is twice? What do you mean twice?
Like I didn't factor the 1 minus t over 20, but I got the
What did you
answer.
do? What did you do? Did
I
you
just
do like they solved it in the solutions? Because in the solutions they went for, okay, they chose an easier way. Fine, but you don't know, like from the beginning of the equation, how to model it to make it easier. So I intentionally did the solution which is harder, because you don't know how will you end up. But tell me, what did you do?
No, I mean the step before this,
Yeah.
I just took the zeros of it. I didn't even factor. But I got like the t is equal to 20 twice. That's the only thing.
Okay, but this is you mean at this step, right?
Yes.
Okay, so this is not legal action in math. You know why, guys? Why this is not possible?
Because
Because
without-
it's not a product.
yeah.
because it's not a product. Because when you are adding something and you got zero, you don't know anything about each term in the sum. You don't know how they ended up to be zero. You know only when it's a product. So if it's not factored, it's illegal to do what you have done. Okay, although you got the same answer.
Okay, miss.
Got it? All right. So, guys, good. Now we got the zero of derivative, which is t equals 20. What's left according to the algorithm? I would like you to, I want to take now a break. I need a break of around 3-4 minutes, and you will tell me I would like you to solve the rest yourselves. And after 3-4 minutes, I'll be back and I'll ask you, okay? So 3-4 minutes break,
Okay.
and please do the rest.
Okay.
All right, guys. So how's it going? So any suggestions about how to complete the question? Hello.
Yes, miss.
Okay, so any suggestions about how to complete the question? What's left after we found the zero? The
Didn't we
derivative?
make an equation at the beginning that E1 is equal to T
Yeah.
and E2 is equal to 30 minus T?
Yes, okay, fine. But before that,
The interval.
what else? Interval. So what did we say about the interval?
It said it's going to have to do with the 30 hours, I think.
Exactly. So it means that theoretically, what are the
0 and
possible
30.
from 0 to 30? Because theoretically, it's possible to spend. What is T, by the way, here? It's the effectiveness. It's the first effectiveness time, right? So it means that 20 hours are spent on the first exam. So it means that, but generally, you can spend from 0 to 30. You can spend 0 hours on the first exam and dedicate all your time to the second exam, right? It's possible.
Yes.
So if this is the interval, guys, what is going to be the last step of the algorithm?
We sub in the
Mhm.
0 and the 20 and the 30 into the
Yeah,
equation.
exactly. So we need, and we'll distribute this now. So we need
The original one.
exactly, E total of 20, E total of 0, and of 30, right? E total of 30. So let's distribute. Who would like to do 0 quickly? We are subbing it where? Okay, I will find the volunteer.
the
So
original
we're
function.
subbing in the original function here. So 0 Mina, okay? Mina 0, Noor 20, Abdurrahman 30, okay? So Mina is subbing in 0, Noor 20, Abdurrahman 30. Guys, quickly. Tell me the outputs. Is it clear what you're doing now?
Miss, can I see the equation?
You want me to go back to the equation, okay?
Yes.
All right, so this is the equation, okay? The very first one is the equation of the total effectiveness. So make sure to sub it in there. And when you're ready with your output, let me know.
For the f of 20,
Miss, we consider A as what? As 2 point what?
I don't understand your question, Mina.
You said that E
No,
is...
you have to input E on the calculator. You don't consider inputting anything else. You have to input E. You don't have calculator or what?
No, I have it.
So you have to input E because E, you have it where you have pi, but you need to press,
okay.
right?
Yeah, okay.
Alpha. All right. Anybody ready?
yes,
Your
No,
output?
I'm still doing it.
Okay. Who's ready? Tell me the
I got
value.
18.5.
Which
18.5
18?
for 20.
Which one are you doing? 20? Okay. In the other period, we got 16 something. Could you
Miss,
double
can
check?
I see the equation?
Can you double
Yes, me
check,
too.
Noor? Because it should be 16 something. Well,
Oh,
but maybe
which
they got it
equation?
wrong. So where do you input it? Here into the first
Yes,
modeled
exactly.
equation.
This is 10 plus, right?
This?
Oh, Miss Natalia, I know why they
Yes.
got 16.
Why?
It's 10 plus, right?
Yeah.
Because they took off the 30. Because at the beginning I did the same mistake. I took off the 30 and did it just T over 10.
Really? Okay. So it
Yes.
should be 18, right? So you're right. Okay.
Miss the
30
equation.
plus.
It's 18.5.
I'm sorry.
Guys,
I'm sorry. I'll just
I'm
remove
writing.
this. So it's 18 point what? Point something.
0.5.
Never mind. Never mind. We just need whole number. Okay. So this is the equation.
Miss, it's okay if I just do plus 0.5 times 10 because 30 minus 30 is 0 and 0 times anything is 0, right?
So you're doing 30, right?
Yes.
Yes. Yeah.
Miss,
I
mine
got
is
12.4.
11.14.
12.4.
Mina, you are 0, right? 11. You got 11.
Yeah,
For
11.14.
0, right?
Yeah.
Okay. And Abdurrahman?
12.4.
12.4. Okay. So so what is the conclusion? The conclusion. That
at 20. So to be at
Mhm.
20 because it's we are maximized.
So this is the maximum. Okay, but
Yeah.
please be careful with the final statement, guys. We're going to write it down. I want you because you know, final
So can you
statement
get
is
the
a
question?
conclusion, right? So if you didn't write
Yeah.
properly the final statement, it's a big problem. So please read the question and get ready to formulate the final statement. Whoever is ready, let me know.
Yeah, I think me.
Who? Mina, you want to
Mina.
try?
Yeah.
Okay,
Yeah.
so let's write down the therefore statement here at the top. Mhm.
Okay. So the at t equals 20.
And
Uh,
I want to listen to
uh,
your final statement first.
okay. At t equals 20, the
Look,
maximum.
Mina, I
yeah.
want to teach you how to make the final statement. Look, you need
Okay.
to take the question the way it is, okay? And
Okay.
take the grammar and everything from there. So, so what's the end of your question? To maximize total
To max.
effectiveness. So start with this.
Yeah.
Start with
خلاص.
this. To maximize the total effectiveness, and then
To maximize
to
total
max.
effectiveness, it will be at t equals
To
20.
maximize total effectiveness. Total effectiveness. Don't forget how many values for time should we mention in the final statement?
2.
Two.
2, yeah.
To maximize total effectiveness. Okay, Mina, go on.
T should be located as 20.
And
Uh,
how many exams is she studying for?
2.
Two. Now
Yeah.
start using human language. So to maximize, we don't say T should be 20. We say we want to speak the human language in the final statement. To maximize total effectiveness, like she should study this for the first exam, that for the second exam, right? So
yeah.
to maximize total effectiveness, she should complete the
Miss
statement.
Natalia, the value was correct. It was 16.65.
Really? Okay, I'll correct
Yes.
it now. Thank you. So she should, Mina.
study
Mm-hmm.
16 point مش عارفة كده.
What are you saying, Mina? 16 point something is the output for the effectiveness. Aren't you? But you are describing time,
Oh,
right?
I mean 20. Yeah, 20.
So she should study 20 hours
20 hours
for
the
20 hours for which exam? For first or the second? Because T here is the
yeah,
time
for the first
for
exam.
E1. So study
Yes.
20 hours for the first exam. For the first exam.
And for the second exam, she should study 10 hours.
And 10 hours for the second
For
exam.
the second exam.
Mm-hmm.
Yeah. Okay.
All right. Okay, good. That's it. I'll just stop recording and then we'll discuss the last part of today's lesson.